On the modern wartime battlefield, the roar of artillery is increasingly joined and sometimes replaced by the high-pitched whine of hundreds of electric motors. In major engagements, Ukrainian forces are now capable of launching thousands of FPV drones in a single battle, creating a deadly, omnipresent threat that the enemy cannot easily escape. This is FPV Explainer, where we break down the most fascinating stories in drone warfare. If you're enjoying this deep dive, hit the like button, subscribe, and drop a comment telling us what topic you want to see next. Your feedback shapes our future videos and keeps us bringing you clear, detailed analysis from the front lines. This tactic didn't emerge overnight. It's the product of 2 years of relentless adaptation under fire. Initially, FPV drones were used sparingly, single, high-risk missions against tanks or bunkers. But Ukrainian commanders soon realized that scale was the real weapon. A few drones could be shot down or jammed. Hundreds, launched in coordinated waves, could saturate Russian defenses, overwhelm electronic warfare systems, and strike targets faster than artillery could reload. Each FPV carries only a small warhead, often 1 or 2 kilograms of explosives. But when dozens are in the air at once, they form a distributed strike swarm. They hunt armor hiding under camouflage nets, chase retreating vehicles, or dive into trench entrances with devastating precision. The psychological impact is as significant as the physical. Enemy troops know they're being watched and hunted at all times. But pulling off such massive operations takes far more than good pilots. It demands industrial-scale production, rapid repair capability, and a frontline launch system that can keep the swarm in the air hour after hour. And that's exactly what Ukraine has built, a wartime drone ecosystem unlike anything seen before. Behind every wave of Ukrainian FPV drones is a sprawling, decentralized production network that blends civilian ingenuity with military precision. This is not a single government factory stamping out identical machines. Instead, hundreds of small workshops, from repurposed garages in Kyiv to hidden facilities near the front, work around the clock, assembling drones from off-the-shelf components, 3D printed frames, and custom-built electronics. This distributed model makes the supply chain resilient. If one workshop is destroyed, production barely slows. Components arrive from multiple sources, often through creative procurement channels that avoid export restrictions. Every part, from motors to video transmitters, is standardized enough for field units to swap and repair on the spot. In some brigades, damaged drones are stripped for parts and rebuilt within hours. The economics of scale also play a role. A single FPV costs anywhere from $400 to $1,000, depending on payload and optics. Far cheaper than guided artillery shells, yet capable of comparable precision against high-value targets. When commanders request a mass strike, they're not gambling on a few golden drones. They're deploying dozens at a time, knowing that even if half are lost to jamming or gunfire, enough will reach their targets to achieve mission objectives. But producing the drones is only half the equation. Moving them to the battlefield in the right quantity, at the right moment, without revealing launch sites, that's where logistics turns into a combat art form. And that's what we'll explore next. Getting thousands of FPV drones into the sky during a single battle isn't just about having enough airframes. It's a logistical ballet under fire. Each drone needs charged batteries, programmed frequencies, calibrated cameras, and a warhead fitted for its specific target type. That means multiple forward staging points, often concealed in abandoned buildings, tree lines, or underground bunkers, where teams work like pit crews at a racetrack. Batteries are kept warm in winter, shielded from dust in summer, and rotated in precise cycles to ensure maximum flight time. Ammunition handlers load explosives ranging from anti-armor-shaped charges to modified grenades, depending on whether the mission is to disable a tank, destroy an artillery piece, or strike a bunker entrance. Every drone is checked against the day's electronic warfare threat map, Frequencies, signal boosters, and even antenna lengths are adapted on the fly to survive jamming. The launch process itself is staggered to avoid radio interference. Operators work in pairs or small squads, each responsible for a cluster of drones. Launch teams are spread out over kilometers, connected through encrypted comms, so no single artillery strike can wipe out a launch wave. In some cases, a mothership fixed-wing drone ferries FPVs close to the target area before releasing them, extending their reach and conserving battery power for the attack run. But once those drones are airborne, coordination shifts from ground logistics to the nerve center, a command network where live feeds from dozens, sometimes hundreds, of operators converge in real time. That's where tactical control becomes just as decisive as production and delivery, and we'll break down that battle management system next. Once the drones are in the air, the battlefield becomes a three-dimensional chessboard. The heart of the operation is the command web, a network of mobile control stations, each linked to dozens of FPV pilots scattered across the sector. These hubs are often housed in armored vans or dugouts lined with camouflage netting, their interiors glowing with screens streaming live feeds from drone cameras. Commanders monitor multiple video channels at once, using digital mapping tools to track both friendly and enemy positions. Targets are prioritized in real time. A Russian self-propelled gun firing from a tree line might get immediate attention, while a moving convoy is assigned to the next wave of pilots. The key is avoiding duplication and ensuring that no two drones compete for the same target unless intentionally overwhelming it in a double-tap strike. Electronic warfare conditions are updated every minute. If a frequency starts to show interference, commands ripple through the network to shift drones mid-flight to backup channels. In high-threat zones, relay drones orbit at altitude, boosting signals between pilots and their FPVs to punch through Russian jamming. AI-assisted target recognition modules, now increasingly common, help operators lock onto tanks or artillery even through smoke and debris, allowing them to maintain accuracy when human eyes alone would fail. This constant flow of information and control turns what could be chaos into an orchestrated storm. But no matter how sophisticated the system, its success still hinges on the last and most critical link in the chain, the pilots themselves. And that's where we turn next. In the end, the most advanced drone is only as lethal as the person guiding it. Ukrainian FPV pilots are the unsung snipers of the digital battlefield, soldiers who may never shoulder a rifle, yet strike with the precision of a marksman hundreds of kilometers away. Many are young, some barely out of school, but they've logged hundreds of hours in simulators before ever flying over enemy lines. Others are seasoned veterans who've traded the mud of the trenches for the glow of the control screen, bringing battlefield instincts into every maneuver. Inside their headsets, the war is brutally intimate. They see what the drone sees: a Russian tank pivoting the fire, infantry scrambling through a trench, the flicker of muzzle flashes. Their hands dance over the controls, pushing the drone through trees, under power lines, even into the open hatch of a moving vehicle. In those final seconds before impact, there's no time for second guessing, only the cold clarity of the mission. Psychologically, it's a unique burden. Pilots must execute with absolute focus while knowing they are part of a swarm that can turn the tide of battle. Each hit isn't just a single kill, it's a piece of a larger strategy that disrupts supply lines, silences artillery, and breaks enemy momentum. And when thousands of these strikes land within hours, the effect is overwhelming. The result is a new kind of warfare. One where victory is measured not just in territory gained, but in how effectively a nation can turn technology, training, and human resolve into a weaponized storm of precision. And as this revolution in combat continues to evolve, one question looms: what happens when the next generation of drones removes the human element entirely?